This is for Year 12 specialists. It comes out of this complex number, circular functions, vectors, trial number 2, question 2b, part 4. But remembering that 2b, part 1, was to factorise and come up with the 2 other solutions. Part 2 is U was in this form. What were the values of R, cos theta and sin theta? Well, this is U, therefore it's here at -1, -3. So R equals the square root of 10. Cos of theta will be -1 on root 10. And sin of theta will be -3 on root 10. Part 3 asks you to find the value of U squared. And U squared is going to use de Moivre's theorem. So root 10 squared is 10 chis of 2 theta. So that's 10 cos of 2 theta plus I 10 sin of 2 theta. Remembering that we can use our double angle formulas. And our double angle formulas, cos of 2 theta is 2 cos theta sin theta. Therefore you can substitute that in and get 3 root 5. There are 3 different cos of theta rules. This is the one I've used, which gives me -5 on 4. Substituting that back in, this is what we get for U squared. Which brings us to part 4. Part 4 asks us to solve Z squared equals U. So this is the same U as this U here. Therefore, it's going to equal root 10 chis of theta, where the sin of theta is -1 on root 10, and the cos of theta is -3 on root 10. Which means Z squared equals R squared chis 2. I'm using beta since theta has already been used. Which means that this is going to be what my angles equal for Z. So Z is going to equal 10 to the 1/4 chis of theta on 2, or beta. So, what am I going to do? How will I find sine of beta on 2 and cos of beta on 2? Beta on 2 first. So I'll use the double angle formula for cos of 2 theta equaling 2 cos of theta minus 1. So here I can move the 1 over. I can replace cos of theta with -1 on root 10. Putting it all over root 10 on root 10, I get root 10 minus 1 over root 10. When I move the, that's what this is. When I move the 2 over, I've got a 20 on the bottom. So I've got 10 minus root 10 all on 20 is the cos squared. Now I know that U is in the third quadrant because it's -1, -3i. So if I halve it, theta on 2 must be in the fourth quadrant, which means I want the positive square root only. Then I can jump over and look at the other form of the double angle formula for cos, because I now know what this is and what this is, because I just worked out this. I can then solve for the sine of theta on 2. If I move this all over to the left, move this one over to the right, then I've got this, which is squared, so I don't have the square root. This is the same as root 10 on 10. Common denominator of 20, that's 2 root 10. So that will give me the sine of theta on 2 is the square root of 10 plus root 10 on 20. Remembering, because I'm in the fourth quadrant, this is going to be a negative square root. So, what have I got? I'm trying to solve for Z, where Z is 10 to the 1/4 chis theta on 2, which is 10 to the 1/4 cos theta on 2, plus 10 to the 1/4 I sin theta on 2. Substituting in these values for cos of theta on 2 and sin of theta on 2 gives me this and this. The negative is on the sine. 10 to the 1/4 is the square root of root 10. Since I've got the square root of root 10, I can put the root 10 with these, which gives me the square root of 10 root 10 minus 10, because root 10 times 10 is 10 root 10. Root 10 times root 10 is 10. There's a cancellation of a 10 there, so I've got root 10 minus 1 over 2. And doing the same thing with the i's gives me this particular expression. Remembering that if one of my values is positive and negative and down here, the other value will be directly up over here, so I can find my other solution, because my real component will now be negative, and my negative I will become positive I, which gives me my two solutions in Cartesian form.